Hello everybody, can you hear me? Okay, the people in YouTube and Facebook can confirm that you can see and hear us.
The audio on Facebook is okay.
Okay, thanks. So today is our last, let's say, lesson. Remember that the next Wednesday we will have another webinar, but with full-time employees. Um, you can ask them the questions about how is, I don't know, how is living at US, how is bringing your life to US, and well, another question that you have. Uh, I think probably at least one of that webinars will be in Spanish. The other one, I'm not totally sure if he wants to do it in Spanish or in English. But remember that you can do the questions in English or Spanish, and you will receive an answer. So please use that opportunity to clarify your questions about the internships and etc. Well, not the internships, the working at that companies, let's say. Also, you can ask about the remote work or, well, any question that you have. So we'll post more information about the persons that we will be giving that webinar. But one of them is employed at Microsoft, is a full-time employee at Microsoft, working at Xbox. The other one is working at Facebook. Oh, I don't remember the team. Gober, do you remember the team?
The what, excuse me?
The team of your friend.
It's something related with hooks, React hooks, and business. I'm not very sure.
Okay, we will post more information about the people that we will be having the next Friday. So, well, come to the next Friday and we will start with today's lesson. Are you ready?
Yep, everything is fine. So
Okay.
I think you can hear me.
Yes.
Okay. Well, so the last class we discussed about the items or maybe the tools that we'll be using throughout our programming interviews. That are the arrays, the strings, maybe the stacks, the queues, and that stuff. But how can we tackle the programming interview with these tools and with these structures? So there is these strategies that we'll use, and they are also called algorithms. So about them, we can learn that in order to use them, the tools and sorry, can you mute your mic, Brendan? Okay. Thank you. So in order to use these tools to tackle the programming interviews, we will use these patterns that we'll discuss right now. So about them, we can see that they are useful for many things. And of course, we can think about other, maybe, sorry, all the view. Okay, thank you. So about it, we can learn that we can use them for many things throughout our interviews, but we'll discuss just a little bit of these ones. So the sliding windows pattern is a pattern that we'll use in linear data structures. So in order to use it is that we will use a window of size k. This window can be larger or smaller, and also can be static. So the window cannot move on size each time we use it, or it can be moved. So in this case, the window is of size 3, and we will move it to the right each time we iterate the array. This window can be used in arrays or linked lists, also in strings, in order to get some maybe some sum or maybe some values that are inside the window. So we can now think that this window contains these elements to use them. So each time we iterate the array, we will maybe in one problem we want the maximum sum in this of an array of size k. So each time we move the array, we will get the sum of this window. We need to do it efficiently, because if we were to calculate the sum each time we move the window, that wouldn't be efficient enough. We'll use actually um, a time complexity of O of n square, and we want to lower that complexity a lot. So in order to use a better solution, we maybe want to just sum the value on the right, or maybe subtract the value on the left, and we want to move on those things. How can we know that we will use a sliding window pattern to solve our problems? Where there are some patterns that we will have, because these interviews are kind of encrypted for us. We want to understand the problem and the questions that our interview is doing before we start actually coding. So maybe we will get an input of a linear data structure, as I mentioned before, that is a linked list, an array, or a string. Also, maybe you are asked to find the longest or shortest substring array of a desired value. So this is very useful for those kind of problems. The two-pointer solution is used a lot in linear data structures also, where we want to keep track of two elements in this data structure. Let's say we have an array or a linked list, and we want to know if there is an element in the beginning and maybe in the end. So in this case, we want to keep track of the first element and the last element in this array. But why? Well, maybe this kind of solution helps to lower the complexity of our brute force or first solution in our problem from n squared to linear, because we just want these pointers to iterate the array or maybe traverse it just once in order to them to fulfill a certain condition. Let's say maybe those two are the sum of a target value, or maybe those two have an element or a pair of elements, or maybe a subarray. It can be also a subarray of elements that are in the center, or maybe in the right, or maybe in the left. So how can we know that we will use a two-pointer solution for our problem? Well, maybe the linear structure that we are getting is sorted, because having a sorted array help us a lot in getting some values inside the array. Maybe a target sum, or maybe having the maximum value and some stuff like that. You can also get a pair on a triplet when you can use 3 pointers, or you can sort these elements if the array only has 2 or 3 elements. So the domino pattern is an algorithm that we'll use a lot in linked lists. In order to have the track of where the head is, or maybe where the end or the beginning of a linked list is. We'll use a node that is not containing any useful information for our linked list, but it is useful for us to like keep track of where it is. In this case right here, we're keeping track of the beginning of the list in order to like swap the values that are in the first two nodes. We can use that, or maybe there is a problem that where you want to delete every element where its value is k, let's say. But having a dummy node, it's easier for us to delete or erase these nodes because we may have, sorry, the values in the beginning. So it is the root and maybe three elements to the right. So we will delete these 4 elements in the beginning of our list, but we will have the track of where the beginning of the list is. How can we know that we will use this pattern right here? Well, maybe we, of course, will receive a linked list as an input, and we will have to know where it is some kind of value. Also, you can use them in a double linked list, sorry, and it is really useful to use it because you can keep track of where it is at any time in the algorithm, and also it is really useful for just lowering the complexity of your solution. A fast and slow pointer solution is a 2-pointer solution that we will use for moving these 2 pointers in some certain way. This is also called the tortoise and hare algorithm, where we will move these 2 pointers in a certain way. So let's say our first pointer is slow and the other is fast. Also, we want them to move in a way that the fast pointer is moving maybe 2 times faster than the slow pointer, and so on until we find some certain condition. In the case that we have in the right, we will get that the condition is that we will find a loop in this linked list. To find a loop in this linked list, we will have to keep running the algorithm until those two, the fast and slow pointer, meet. And then we will have to calculate the distance between the beginning and the, from the beginning to the, to where they met, so we can know where the cycle begins. So this is really useful, not only in linked lists, but also in arrays, because it is harder to think that these two can met in some way, or maybe in some time in this algorithm, but we will get them eventually. So you just have to trust. So yeah, this solution is also really efficient. So I would recommend it to use it. So the merge intervals algorithm and pattern is like having in mind what these 6 what the cases are in maybe a problem that gives you an interval of times, or maybe an interval of space in this problem. So we will have to keep in mind that we have these 6 possible events that will happen throughout our problem. That maybe we have 2 intervals of time, and A can or cannot overlap B. The first case is that A overlaps B. The first case that A do not overlaps E, and they do not connect. The second case is that A and B overlap. but B ends after A. The third case is that A completely overlaps B. The fourth case is that B overlaps with A, but A ends after B. The fifth case is that B completely overlaps A, and the sixth case is that B and A do not overlap, but B is before A. We will get these problems as maybe tuples or an array of intervals. So it is really easy to understand where we can use it at first.
Okay, so now we're going to start talking about backtracking and more probably recursive algorithms. So backtracking in interviews is pretty common. Usually the backtracking technique is basically doing a brute force over some either graph or possibly some array, but you can always like transform this array into some type of graph or something that you can go through, right? So you can apply this technique, which is basically traversing through all your possibilities. So here we built up a tree based on an array here on the left. So notice that we have several possibilities of how to create combinations of this same array. You can use it to create several subsets, or just the key idea of this is to create all your possibilities and then choose the one that you were requested for. And notice that this can be applied in arrays, linked lists, graphs, several data structures. So it's not just for something, okay? You can always transform one thing into some other thing that can be traversed in all possible ways. So basically, this is backtracking, and it is a very common topic or strategy that we use in interviews. The next one is BFS or DFS. So in BFS, we traverse, we have a tree here. So in BFS, we traverse it level by level. So what I mean here is that we, so in the first example, we have a node with a level of 0 in the root, and then all of its children will be in another level. So let me write here. So these nodes will be in level 2. And then if we go to the other nodes, then they will have the next level, which is level 3 right here. So all of them will have this level. So this is how we traverse a tree or a graph using BFS technique. The most common problem, I think, is getting the shortest path to some node in some graph, or some other common problem in interviews is print the lower level of the tree, or print just the nodes that you see if you were in the left. So those problems can be easily solved using breadth first search technique. On the other hand, depth first search technique is a little bit different, because here is more like kind of backtracking, except that in this one, we're not going to get all the possibilities. We're just traversing the tree in some way. So we're passing through each node just one time. And in this case, if you follow the red arrows, we're going from 0, then 1, 3, 4. And then we're going to use recursion here to traverse through the tree. So what will happen is that we will go back to 1, back to 0, and then we will go to node 2 here, and then we will start doing the same thing. So this is depth first search, and some problem that involves depth first search. Well, there are a lot, but probably a common one is just to search for some value in the tree, or probably you have to combine this technique with some other technique, probably dynamic programming, or probably some other graph algorithm. So a common algorithm that uses DFS, one of its ways to solve it is a topological sort. We will talk about it later, but just for you to know that there are a lot of algorithms that involve a graph traversal, and these are the two most important ones: breadth first search and depth first search. Okay, so binary search. Binary search, I think, is the most common. Is I think super common in interviews. This technique improves the search complexity in either an array or some monotonic space. So what I mean in a monotonic space, so if you don't have an array, probably you could have some function. I don't know. So yeah, probably some function like this one. It would be this. So I think this is Fibonacci series like this. So notice that what is important to observe here is that we're going in just one way, right? So this is sorted. So this is just a sorted sequence that is going well, it's going up, right? So it's growing increasingly. So binary search can also help us in these scenarios where you just have a function instead of an array. So no need to have an array. You can also use binary search over something else, not necessarily an array. And then how does binary search help us? So let's say we want to find some value in our space. Let's use this function. Let's say we want to find number 5. So linearly, we could check first, go from left to right. So check them all, compare them with 5. And if you ever find 5, then you return like, okay, I found 5. And you return true from your function, right? But binary search can optimize this because this sequence is sorted or is in increasing way. How does it do it? Well, it uses the fact that we can ignore half of the information in our space. So if we observe this array, which is just sorted 1, 2, 3, 4, 5, 6, 7, notice that if we're looking up for 5, we can ignore all the left part of the array because we already know that it's not going to be there. So we go to the middle, we compare, are you 5? And then if you are not, then we would just say, are you smaller or are you greater? So it's easy to think that if the item found is smaller, then you can ignore all your items to the left. And if it was greater, then you should ignore all the items to the right. And in this way, you can reduce your space a lot. And actually, you reduce it in a logarithmic complexity. So instead of doing a linear search, which will cost you O of n, you can do binary search, which can cost you just log of n, and then you can get your result. This is a very common strategy that we use in interviews. It can be combined with several other strategies, but alone it is very powerful. Common problems that come in interviews about binary search is count the amount of repeated items in the array, and they give you the item that they want to find, right? So for example, if here we had like number 5 repeated 3 times, then the answer should be 3 times. And for that problem, you can use 2 binary searches and just search the number 5 and go through the end, and then search for the number 5, but then use lower bound and go all the way to the left, and then just subtract the difference of the answer, and then you will have how many times does the number 5 is getting repeated. Of course, you will need to practice how to get those special types of binary search, which are called a upper bound and lower bound. So I'm going to write it here. So it is upper bound. So if you use C++, these are the names of the function that already implement this. So the only exception is that you have to notice that they just works for array. So if you don't have an array, you will have to implement them yourselves. I think in Python, it also has this type of function. I just don't remember its name. And I think Java also has them implemented. So if you have an array, then probably you can ask your interviewer if you can use these functions right here, or if he wants you to implement those. So remember, always we need to ask about
upper bound and lower bound also works in kinds of maps or sets.
Oh yeah,
they have like map.upperbound and something like that in C++. So you can also ask if you want.
yes, some data structures. also implement these functions. But well, the most common thing that you will be using in an interview is implemented yourself. Usually the problems are not that hard. So the actual objective of the interview is to know if you can implement a binary search here. Yeah, so that would be for binary search.
I want to add, well, first you have a question, Orendon asked if, what is the tool that you use to draw in place?
I don't remember its name. Let me see. I think it's Flame Shot, or let me see. Yeah, the name is Flame Shot. So like flame of fire, and then shot, like a gunshot. Flame Shot. That's the name. I can write it in the comments later. What was the other question?
Carlos mentioned that he got a cheap Wacom tablet. Wacom
Of
tablet is
course.
for draw. I think professional
Yeah.
draw. I mean, my brother has one of them. You can also. I think you also have one, no, Sergio?
Oh yeah. I also have one. So that's the one I use to physically draw, and then the application to draw in the screen is called Flame Shot. Yeah, I have the small Wacom tablet, which is about, I don't know, like $30, I think. Yeah. Okay. So do we have any more questions?
No, but I want to share with the people. Well, LeetCode is the platform that I think the most popular one to practice for your interviews. And LeetCode has a course for binary search. I will share the link in the chat. Has a course that for me at least was really cool because I know another modifications for the binary search in order to do different ways, different solutions. No, I sent the link in the chat if you want.
Oh, okay.
It's in the explore
check it out.
section. But yeah, you can take a look of them. It's really cool. Are little modifications like how manage the condition in the while, or how make the comparison and something like that. So you can take a look of them if you want to learn a little bit more about binary search.
Nice. Yeah, so here they explain a lot more things. Pretty nice.
Yeah, that's everything. You can continue.
Okay.
Well, I only want to add that these topics are based on two articles from Dev2. Are in the chat, but I will share also. I mean, we modify them, but the main two articles are also really interesting if you want to take a look. Only, be careful because we noticed a few errors when we were reading them. So this is one of them, and this is the other one. So you can take a look of them and learn a little bit more about this. They include like examples and I think code in some of them. So it's another good resource. Yeah, sorry for the interruption. You can continue.
Perfect. Okay, so I'm just going to mention one last thing about binary search, and is how do you get the midpoint? So you can see here that we're using this formula called star plus and minus star divided 2. Notice that we need a parenthesis here. So this definitely works fine. So there is another formula that we don't commonly use, but is for a reason. And if you mention this reason to your interviewer, then it will give you like a plus. So usually the other formula is just doing this L plus R divided 2. And this is totally fine, but we have to remember that we're using computers, and computers support at most 64 bits numbers, right? At most. Usually, maybe you want to work with just 32 bits. So maybe 32 bits should be enough to solve your problem right now. But with this formula, notice that we are making this addition here. So what happens if we add the biggest 32 numbers together? So we're going to exceed the limit of 32 bits, which I think is more or less 2 9, something like that. So if we add these two numbers together, we're going to be exceeding this limit. And that's a problem, because in your program, this will be an overflow, and the result of this operation is not going to be what you expect. So a probable solution would be, okay, just use a long integer instead of just a single integer. But in this way, you will also use more memory, and the time complexity will increase a little, but it will increase. So the trick here is to use the other formula, which is just the one that I mentioned, which is just this one. Notice that here we are just adding the half of end minus start. So this is guaranteeing that we're not going to have any overflow. So if we have the same case for 289 plus 289 divided 2, we will be doing first subtracting them both and then dividing them by 2, right? So this will not create any overflow. So if you mention this to your interviewer, this will definitely give you a plus, because he will notice that you know also more internal parts of the compiler or of the programming language that you are using. Okay, so now that's it for binary search. I totally recommend you to study more about this topic. That will be it for my part in this topic. Okay. K elements. This is another common pattern or a strategy used. So, and this strategy is commonly solved using a heap or using what is called a priority queue. Usually the problem will come in the form of, I want you to keep K elements, I don't know, maybe just easily accessible, given some array of information. So here we have the example that we are dynamically inserting or moving some elements in the array, and we want to keep like the most important ones in some accessible position. And the data structure that can help us to achieve that is the heap or the priority queue, because this one sorts the items while you insert them. So if you start extracting each of the items from the priority queue, you will get the list first, then the second list, then the third list, then the fourth list, and so on, so forth. Also, you can apply it in the other way around, which is you want to get the bigger items, just take the first biggest item, then the second biggest item, and so on and so forth. So this is very, very useful. There is also another variant of this strategy, which is a common problem that I know that also relates a bit with this strategy, is try to sort a K list. Try to sort them all. So I give you K list, and those K lists have size, I don't know, maybe n, and you want to create a new list, so just one list with all the lists merged. So in this problem, you also use this heap. So you can use a heap that keeps K items on top. So this technique is also used in those kind of problems. So notice how we can transform these ideas into some other that are pretty similar, but I mean, the important thing is that you get this intuition of how to use these data structures in your favor. So just remember that if you have to do something with K elements, you could start thinking in priority queue. So this is not a rule, but is the most common way to do this kind of problems. Manuel, I have a question. Yes. So the question says, do they also ask to implement the DS from scratch? What do you mean by DS?
Data structures, I think.
Oh, I see. Okay, so implement the data structure. So it will depend on the interview, but for example, this type of data structures like the priority queue or probably the stack, the queue. So the most common ones is rarely seen that they ask you to implement those. Usually, you just use the ones that are already implemented in the programming language. However, they could ask you to implement some different data structure. There are several problems that involve implementing some data structure, and this data structure might involve some other algorithms or some other data structures inside. So, for example, we can think of a persistent array. We could use a binary search inside, and we can also use a map or what is it called? A balanced binary tree. So they can ask you to implement the data structure, but not necessarily these ones. The most common ones is very rarely seen.
Well, I
Also, I
would say that.
can.
Oh, go ahead.
Okay. Okay. I can add something more. And this is a special case in object programming languages, for example, Python. So it's good to know how to implement this kind of like data structures using only like object-oriented programming. Because yeah, as I said, let's say that I was like doing my internship, well, my interview in Python, and maybe the interview want me like to implement how it's like, let's say, a linked list, or maybe I don't know. So I can give you the advice of like, all you can learn how to build these like data instructions in a simple way, going to let code and do some problems related to that data structure. Let code provides you the implementation and the code for that data structure in the simplest way. So yeah.
Yeah, I was going to add something like that. Also depends of the problem. If the problem is, let's say, focused in the data structure, obviously you need to implement them. But if the problem is use the data structure or something auxiliary, probably you don't need to implement them.
Right.
And also applies with the binary search. The binary search is the same case. If it's the main part of the problem, probably you need to implement by hand.
Yes, totally agree. Perfect. Okay, let's move on. Okay, so now we're reaching topological sort. So this is another graph algorithm. Is not so common, but particularly in interviews, is commonly asked this problem. So they give you a let's say, so some courses in the school, and these courses depend on other courses, right? So like they give you dependencies, and they want you to find an order that satisfies all the dependencies. So for example, if I have a condition that 5 depends on 2, so first I have to take 2 and then I have to take 5, then if I do something like 2 and then 5, this will be like completely wrong, right? I cannot do this. So and then probably you're given like 1 depends on 2, and so one correct order here could be printing first a 5 which depends on 2, then a 5 depends on 2, then 1 depends on 2. So probably here it could be a variation. So we have 2 options here. So we can put 2 here as a dependency 5, and then the number 1 also over here, right? So 1 depends on 2 directly, but we can also put it after 5, and there will be no problem. Also, another possible option would be just to build a graph like this. So if both depend on 2, then we can have this variation. So notice there are several ways to try to sort this kind of data. So that is what topological sort does. It gives you an order that satisfies all the given dependencies. And these dependencies are usually given in pairs. So usually you will have a function that will have a list of pairs, and these pairs will mean dependencies. And then from those dependencies, you will need to build a directed graph. And from that directed graph, you will have to run this algorithm, which is a topological sort. You can Google this algorithm, it's very common, and you will probably find 2 solutions. one solution is using depth first search, DFS, or the other solution is going to be using breadth first search. So both solutions work pretty well. The DFS solution is going to be shorter, but the breadth first search solution can be more expandable. So if the problem has a variation, like you want to sort the order in some particular way, then if you use the breadth first search approach, it will really help you because it's more modifiable. So it's easy to modify if you use the BFS approach. And I think it's a little bit more intuitive than the DFS approach. DFS approach uses a stack also to keep these nodes. So basically what it does is just, it goes through the arrows and then it ends in the node that doesn't have any more nodes that depend on it, right? And then it starts building the stack from right to left, or from the end to the start. And at the end, what we have to do is just reverse the stack, and you will have like an order. So in this case, we could have 1 and then 3. Depending on how you traverse the tree, then you would have your stack being filled in this way. So first the end, and then all the way to the beginning, and then you just reverse it, and then you will have the topological sort corresponding to your graph. That's a DFS. Then breadth first search is just using a queue and using the fact that there are some in degrees edges. So what I mean by in degrees, so for example, let's take this node 4, and we can see that it has 2 edges inside. So this one and this one. So we will call this in degrees. So the in degree of 4 is going to be those 2 edges. So here is equal to 2, right? In degree. And then all those edges have this in degree. And we use this in degree to start our BFS. So notice that if there is a node with in degree equal to 0, then that means that we can put that node first, right? So for example, 7 here. 7 has in degree equal to 0. So that means that no one, well, it has no dependency, right? It does not depend on anyone else. So we can start our DFS from here, and then start exploring the graph, going to those nodes that are with in degree 0. So for example, if I explore 5 and 6, then I would reduce its in degree from 1 to 0, because since I already processed 7, then it's going to be removed. All right, this edge is going to be removed. And then we keep advancing, and we do the same for 4. So if we visit here first, then we subtract 1. So if its in degree was 2, then subtracting 1 will make it just 1. And then once we reach 4 from the other edge, its in degree will be 0. So now we can be able to process 4, and so on and so forth until we reach the last node. Usually I find this second solution more intuitive, and as I said, more modifiable if the interviewer asks you to do something more special. So I don't know if I have any questions. I think not. So if not, then we're going to have a special session about
well, return a little bit,
okay.
Sergio.
Oh, okay.
Okay, I only want to add that these topics are not, well, let's say that are the most common ones, let's say, or sorted by
Complexity?
complexity or importance that we think are, well, they have in the interviews. Well, probably the binary search need to be more at the top, but well, the important point here is some of these topics like topological order or the top K elements will depend of the company that you're applying for. They are like, for example, really unusual in companies like Microsoft. But topological order is a topic that, for example, Sergio has in Facebook or Google. I don't remember.
Yeah, it was in Facebook. They actually just asked me this same topic, topological sort.
Yeah, so like if you need to practice something, or I mean, these kind of topics you can let it at the end of your study plan and focus in the first ones, because the first ones are most common than the last ones. So, for example, a funny topic is with the top K elements. We have a meme in our school because we have, I think, four friends that have had a problem called closed K points. You can find in the lead code. And well, the solution is using this, the heap to solve it. But none of that friends have received an offer, and we consider that the problem is good. So probably sometimes depends also in the next part of the session that will be the think aloud. But uh, I mean, surely if you need to focus in topics to study, focus in the first ones, because the last ones are less common than in the interviews.
Right.
Okay,
Also,
now yeah, go ahead.
if you are from this earlier semesters in the career, just remember in the question of if you need to implement data structures, just remember to study pretty well linked lists. They're pretty common in earlier semesters of the career, and in that case, you will have to implement them, or probably a circular queue or something like that. Just in those cases, you will have to implement those data structures. That's it.
Okay, and also as Gober said, if you can try to implement all the data structures by your own, will be really useful not only for your interviews, also for your development as a software engineer.
Okay, so we are going to explain what Think Aloud is, because we have been mentioning Think Aloud in practically like all our presentations. And what is this Think Aloud about? Well, basically, it's like very simple, but most of the people don't understand it very well. I'm not sure, but Think Aloud, it's only like, uh, as the word said, think aloud. Let's put an example. When you're practicing, or when you are like trying to explain the problem to your interviewer is not going to know what it's inside your mind, right? Obviously, your thoughts are inside your mind, but no one can like read them. And you need like to begin to get used to think aloud, because this is the only way that you can like explain what's going on in your mind, in your train of process, in your thought process. And how are you going to like develop this skill? Well, basically, an advice that I can give you is, when I was like practicing for my interviews, uh, I used to like pick a problem and try to emulate the environment as close as possible to the real interview. So I was like talking to the computer, like saying, like, okay, I got this problem. Let me clarify. Did I understand very well? I know that my computer wasn't going like to answer me, right? But I was like forcing my mind to like condition myself to do the same steps for all the questions. And basically, when I was like in my real interview, it was like super easy to me, like to handle this kind of like situation and the questions, because I was like training my mind to say like, okay, I'm thinking, but I'm like always thinking aloud. And it's like a flowchart. Do you remember like the flowchart that we already like sent to you? It's the same, right? You need like to clarify, think aloud. You are thinking about each cases, think aloud. You have questions, think aloud. Uh, Mention the different approaches to that problem. Again, think aloud. And basically, this methodology or this strategy is really going to help you because you are not going like to miss anything, and your mind is like going to be fixed, and it's going like to say like, okay, I know that I don't have like to uh, okay, I'm so sorry, to like not think aloud. And also I can give you like the advice to do as much mocks as possible, because even if you are like uh, practicing by yourself in this like particular part, maybe you are not aware of some of the mistakes that you are doing it, and in this part you need like to spot them as fast as possible. So when you're like thinking aloud and practicing by yourself, also do mock interviews, because when you're like doing mock interviews, it's like putting in the table if you're like doing the things right. If you're doing the things right, you're the person that is mocking you is going to say like, oh, okay, cool, your communication is good, and you can like he will understand what's going on in your mind. Do you need any more commentaries?
For current one, like we are not sure. I think there's some still
Well,
some
I don't
debate
have.
if we want to
Well,
show.
first of all, I want to ask the answer the question of Orendon.
Okay, but we are not sure
Yeah,
how to
as
work.
Carlos
Like we
said,
want to
you have
do
topics in,
that
sorry,
option.
in lead code, you can filter the problems by topic. You can filter by linked lists, by trees, by graphs, etc. So it's a way to practice. And well, also in most of the platforms, a platform that I really like is someone called InterviewBit, and they have like a, who is called roadmap. I'm not remember. I don't remember the name.
Yes. So
But well,
I
for me
saw
was
the
really nice
internet
because I was like
to
following the path.
computer.
Picking practice, Sergio, please.
So I mean, it's not only for
Programming.
the
Yeah. Oh well, you have also another topics like system design there. Well, you have this path, and well, for me was really useful. And for example, I know that my weakest topic was graphs, so I solve all the problems that are there about graphs, because at least for me, give me confidence to during my interviews. And also in most of the platforms, you can filter the problems. Also in HackerRank or something like that. I suggest you to focus in use lead code because it's the most popular one, but for some of the problems there are premium. Uh, if you want to solve one of these problems that are premium, probably you can take the title of the problem, put it in Google, and almost sure in other platforms you can find them. And related to the think aloud topic, it's really important the think aloud part, and well, we mentioned this part in
I
some
feel
of
that
the lessons, but when you are practicing, please try to let me share this. Try to think aloud while you are practicing. Doesn't matter if you looks like the crazy woman with cats of the Simpsons. You need to start practicing your think aloud because it's really important, and sometimes it's really difficult because um, it also is important for the teamwork, but it's something that we really don't practice. Like when you solve a problem, you usually, or for example, if you're from competitive programming, you actually take the paper, try to solve the problem by your own, and when you have an idea, you talk with your teammates. And it's really a bad practice when you're applying for an interviews because in this moment you need to all the things that you try in the paper and the ideas that comes to your mind, you need to uh, speak loud about them. So start practicing with these problems. Well, for me was really useful, and also will be really useful when you start practicing with mock interviews. Someone else want to add something?
Yeah, just a well, first Can you hear myself? Yes.
Yeah,
Um, just one thing. Whenever you practice by yourself, it is recommended that you also practice these things. So just thinking out loud, not just solving the problem, but like imagining you in the situation of being in an interview. So just like imagine it and do it. So think out loud actually, and this will help you pretty much. It helped me pretty much, and then uh, all of my peers use this technique, and it's really helpful. So of course, it is even better if you do mock interviews, but this is also a way to practice, which is really good.
Well, if you don't have more
I
questions,
have
probably we will
a
finish today
to
earlier.
I think Orendon is typing a question.
Well, it was only a comment. Yeah, if you have any questions about anything, will be our pleasure. You can send a message to us, to the page, to the well, in the Discord, or well, in any social media that we have, and we can answer your questions in the future. And also, obviously, you are well. I don't remember the command exclamation Discord with the first one capitalized. I don't remember the command, but you can join to our Discord. In our Discord is where we do the mock interviews, and we also well, do another activities to help you to prepare for your interviews. Also, please, the people that wants to get a review of your resume, you can send a message to us, and it will be our pleasure to help you with your resume. Also, some of our teammates are working in improve your English. Is a really important part of your of your preparation, because the English is not only to express your ideas, also to when you are working, you need to communicate with your teammates. So please try to practice your English, start seeing videos in English, movies in English. Well, one thing that helps to me was I started with movies in English, subtitles in Spanish, and in some moment I switched the subtitles to English, and in some moment I don't use the subtitles anymore. So that helped me to force myself to understand the English better. So continue practicing with you about all of these things that we mentioned during the lessons. And well, someone wants to add something else?
No, I think notes.
Yeah, I want to add something.
Okay.
yeah. I think the answer about the life question.
When are you going to return to this workshop?
So what was the question?
Uh, if this workshop is going to be available again on another moment.
Oh, yeah. This workshop, well, we do this workshop each semester. So probably the next iteration will be July, or yeah, more like July or August. Um, Also, you have the all the lessons recorded in Facebook and in YouTube. I think we have the playlist in some place. Let me share it. So if you want to rewatch any of the, let me send the playlist. Playlist Facebook and playlist YouTube. Okay, so you can rewatch any of the lessons in any moment, and the next iteration will be, as we said, probably July or August, because it's the next recruiting season. So it's really important.
Yes, I think we have another question from Orendon. Have you get asked bitwise combinatorics and other topics in competitive programming? And the answer is yes. Not so often, but yes. Um, I have had interviews in Google also that asked me bitwise problems and combinatorics problems. I have just seen them in Google, no other company, but I mean, this is still a probability that they might appear. Anyone wants to add something? Okay, so we have another question. Does the topics or patterns change a lot for those of you who got into full-time positions? Probably Gober is a better possible
Uh,
answer.
yeah. What do you mean? Like, if those pairs are going to be seen in a full-time position, or what?
So what I can say is that the algorithms, I think they are mostly the same. What changes is that you are asked a system design interview also.
Oh, I got the question. I'm so sorry. Uh, yeah, I would like to say that they're not going to change too much. Maybe they expect you like to solve a little bit more of like more challenging problems because you know you are like at the end of your university career, right? So maybe you are not going to be asked graphs. Again, this is it depends on the company because for example for internship Facebook asks graphs, but let's say that one company is not interested in graph for a full for an internship, but for a full-time position they are going to be asked graphs. This is an example. Right. Yeah, but you need to study like all the patterns are going to apply for all the positions that you apply. More questions? More questions?
No, I think that's it.
Oh, Carlos put something in the chat. Knowing my experience, when you get into a more senior position, they will expect a faster solution and give you less hints. Oh, okay. So you got like the answer right there.
Perfect. So I think that was it for today's session. I think we can leave it here, right? Igor or Megatrolls or anyone wants to add something else?
I'm cool. Do you need more comments?
Perfect. So okay, so I'm closing it this one. Thank you for coming. Thank you for our mentors and pretty nice questions. See you on Friday.